So welcome everyone to the CHBE Open House. We're very happy to kind of have you here on a Friday night. Really wish we could host you in person, but these circumstances, you know, this will have to do. But at least things look like they're looking up, and we'll be able to kind of greet you in person in September. So that's a good thing. So my name is Gabriel Potvin. I am a professor here in the Department of Chemical and Biological Engineering. I am currently in the real life lab, so you can live vicariously through me as we explore these kind of facilities. And so the whole point today is to get a chance to kind of answer some of your questions, tell you a little bit more about chemical engineering and what chemical engineers do. So here's the schedule for today. I'm going to give a quick 5-minute presentation. I'm a professor, so I like the sound of my own voice, so it might be up to 7 minutes, but then I'll walk around in the lab a little bit, show you a few stations, and give you examples of things that chemical engineers are work on and that you will work on if you come here to study in the lab. And then you'll get the chance to hear from some of our current fantastic, outstanding students on the kind of work that they're doing. And then we'll have an open Q&A session so we can answer any question that you might have about the program or about the experience here. So yeah, so let's get started. So if you give me a second, I will share my screen and we can get started with a quick presentation. All right, so hopefully everyone should be able to see this on the screen. So let's get to it. So the first thing we do when we have these presentations is we ask you to imagine a world without these things, a world without clean water and food and fuels and medicine and all sorts of wonderful things, and perhaps worst of all, a world without cell phones. And the punchline to this is, of course, what you are imagining is a world without chemical engineering. So chemical engineers are involved in all of those different applications. They're involved in all sorts of projects because the things that chemical engineers do underpin our society and the physical world around us. And so the skills that chemical engineers have allow us to contribute to all of these different fields. So what do I mean by this? So it's a kind of future-proof technology. So what we mean by kind of this is these are the kind of pillars of our discipline, if you like. They're not actually very different from what you'll see in other programs in that we use chemistry and physics and math. So we offer 2 programs. We offer chemical engineering as well as chemical and biological engineering that diverge a little bit. We can talk a bit more about that later if you like. But those in the biological program, we also use biology, right? And we use these things to design processes, to look at how the world around us works, and to design processes to transform materials, to go from point A to point B. And so this requires knowing a lot of stuff, having a good grasp of how the world around us works, so that we can design these applications, these processes, to make some value-added kind of products, or to make the world do what we want it to do. So the way I like to look at it as a professor is what we do in chemical engineering is we learn how the universe works. We learn the rules of the universe. The universe around us is composed of matter and energy. So we spend a lot of time learning those natural laws, learning the behavior of matter and energy around us. The whole point being, once we have mastered that knowledge, we can bend the universe to our will to make these kind of processes. And the laws that we use, the natural laws of matter and energy, they're applicable whether we work on a small scale, right? So if we're working in product development, like you see on the slide here, these laws applies to molecules or cells, all the way to those big industrial plants that manufacture the products that we use every day. The same laws apply, which is why chemical engineers are so versatile, why they're so kind of powerful in terms of discipline, because we're able to kind of apply our skills to all of these different scales and all of these different applications. So I'm not exaggerating. So what you have on the list here is a list of the grand challenges for engineering for the next kind of century from the National Academy of Engineering in the United States. And so these are the ones in which chemical engineers have a major role to play. It's the vast majority of these applications, because the things that we learn allow us to directly contribute to these different fields and be leaders in this field. So when I say we're designing processes, is we are designing a series of steps to transform some materials and to kind of transform things like solar radiation into electricity that we can use. And so we use our knowledge of physics to kind of go through, and so that addresses the first point on the list. And so one thing also to kind of mention is, for those of you that like being in charge, right, like having that kind of big picture kind of image, to be a good chemical engineer and design that process, you have to know a lot of stuff from all of the other disciplines as well. So if you're designing the process, you have to know what the electrical engineer is going to do for the control system. You have to know what the mechanical engineer is going to do for the reactor that they're building for you. You're the one calling the shots. You're the one making the decisions to kind of oversee the process as a whole, which is a really cool thing to be able to do it from that scale. So I'm just giving you the Coles notes kind of here of kind of what it is that we do, but that gives you an idea of chemical engineers' role in terms of engineering in general. So some of you kind of here, you might have in your head that chemical engineering equals oil and gas. There's obviously some of that, right? That's where the discipline came from kind of a while back. There's less and less of it though. I told you we can apply our skills kind of everywhere in any discipline that you can imagine. And so one thing that's really woven into kind of the work that we do is really sustainability and protecting the world around us. It's not just a matter of let's see if we can technically do this, but let's say we can do this without damaging or even while improving the world around us. So those of you interested in things like pollution remediation or getting rid of plastics in the ocean, or kind of mitigating climate change, like this is really built into the discipline, and we do a lot of that in the department here. I am in the labs now. We have some fantastic, top-notch, world-class facilities in which you'll be able to get hands-on experience with these processes and these ideas that you cover in the classroom. We'll look at a few things kind of in a kind of few moments. And we really value this kind of hands-on experience. So what you have on the screen here, this is an experiment I did with some students. We took some jellyfish DNA and we put it in bacteria to make them glow green like this. And this was a creative student decided to do a bacterial smiley face for their kind of experiment. So we really do value both the kind of theoretical and practical applications, right? So we also have a fantastic student experience. I'll let the students talk a little bit about the stuff that they do. They'll be much more convincing at this than I am, or trustworthy, I should say. But one thing that we really kind of hold dear in the department is the student experience. And we really have a culture of wanting to help students achieve what they want to achieve. And what you see on the screen here, this is a slide of our third-year field trip. So all of our third-year students, we take them to a field trip in northern BC, we take them to Alberta to visit different facilities and different industries to get a feel for what chemical engineers do, to get a chance to network, to go on a great road trip as well, and kind of get like a tightly knit as a kind of cohort, as a community of people working together. So this is a great experience. It's unique to our program. And so this was canceled this year, of course, but we're going to resume it. So by the time you get to third year, you'll get to participate in that. And this is a carbon capture facility. So you might have talked about carbon capture in an APSI 100 or 101 class. You get to go see it in real life, which is an exciting thing. So when I say kind of we have outstanding students, I'm not just kind of buttering up the students we have in the room with us today. We really do have fantastic students that achieve amazing things. They participate in all sorts of undergrad student design teams. They'll talk to you about that, but we're very proud of them. And they'll talk about the projects they're working on, right? Win all sorts of awards at the local, national stage. I told you chemical engineers are involved in so many kind of industries. Here's a kind of short list. Obviously, it's not exhaustive, but you'll see we have people that work everything from kind of chemicals and energy, like you would expect a stereotypical chemical engineer would do. But we have a lot of our students in renewable energy and food. Some of them go to law school or kind of medical school. They work in electronics. Whatever you can imagine, there's a chemical engineer involved. Don't take my word for it. Here is a list of some students and kind of where they are. So we have some on the left in kind of medical applications. In the middle, they're in renewable energy. On the right, they're in food. We have people all over the place in terms of energy. So if you're interested in those things, of course, there's a big aspect in chemical engineering to this. We have some of our students in some of the best graduate schools in the world. We have people that graduate from here and go to MIT and Caltech and U of T. People go to law school. So whatever, chemical engineer will really give you a pathway to whatever it is that you want to achieve. So I'm pretty sure I went way over the kind of 5 minutes I was supposed to kind of do here. I told you this would happen. It always does, no matter what my efforts are. So we can have some questions here. So what should we do? Maybe Christina or, so, okay, I have a question here from Farah. Maybe I can answer a quick one now. What's your question, Farah?
Hello, thank you so much. I wanted to ask, to my understanding, integrated engineering is a discipline where you can combine different disciplines. And I'm really interested in chemical and biological engineering, but I was interested in some other disciplines as well. So I wanted to know, is chemical and biological engineering a discipline I could take within integrated engineering, or is that not necessarily possible, since I know it's like very broad and it's really it's a really heavy it's a really heavy discipline, I should say.
Yeah, I get it. So I think Nika has her hand up. She'll be able to kind of answer that for you better than I can, I think.
Hi.
No?
So
Yeah.
actually last year I was in integrated engineering. 2 years ago as a first year, I was juggling the decision between chemical and biological engineering because I knew I was super interested in that. But then I also loved everything else that had to do with engineering and I wanted to try everything out. So I did go into integrated engineering. It's a wonderful program. You get to experience so many different courses, especially on the mech and elect side. What I found personally in second year was as I was planning my degree, as I was planning my courses, I wasn't actually able to take as many chemical and biological engineering courses as I would like to. And so what I found was if you know you like CHBE, and you might as well dive in. But if you think, well, maybe I do want to combine degrees, it is a good option. However, you won't be able to get as much depth within the courses as you would like, probably. That's my little 2 cents.
Great. So thanks a lot. So I have a recommendation here. So because we're already kind of getting questioned, if you'll just give me like one example, I'll show you while I'm in the lab here, and then I'll just introduce the students so they're kind of they'll be able to talk a little bit more about their experience. So if you follow me, it's going to rattle a bit. I'm on a kind of a card here, so we can kind of move around the lab, so you'll get a sense for the facilities. So what we have on the screen now, this is what we call the distillation column, and this is obviously an industrial scale one, right? So this is what we use to separate two liquids based on their volatility, right? How easy they are to evaporate. I told you we design systems through steps to kind of transform one thing into another. And so we do that through unit operations like a distillation column. So what you see on the screen is a big industrial one. What you see behind me right here, this is what we call a lab scale one, right? A scaled down version. So this is where you're going to be able to work on a lot of these applications to learn how they work, to get experience controlling them and manipulating them. You're going to do this on computers using kind of cutting edge software. You're also going to be able to do this manually to get a better understanding of how these things work. So you spend a lot of time doing that so that the skills you develop here are directly applicable to processes. So we have examples here. This is a heat exchanger. Doesn't look like much, but you'll work with some heat exchangers here. Very important part of the process, right? And then this is in a reactor. We don't encourage students to go down reactors like this, right? But gives you an idea of these huge reactors to produce anything you can imagine, from kind of medicine to medicine, to food, to kind of energy, to all sorts of stuff. But we'll get some experience there, right? So to give you a sense of these things, if you're interested in any particular application, I can see if I can walk around and show you some of the things that we have. But with that, I think you listened to me long enough. So I'm going to introduce the kind of students, right? They'll be able to tell you a bit of who they are, why they're in chemical engineering, and what they're doing at the moment. So I think we settled on the first one will be Amelia. So Amelia, it's all yours.
Thank you. That was a wonderful presentation. Hello, everyone. My name is Amelia. I am a fourth-year CHBE student, currently on co-op this year. So I'll be actually doing my fourth-year courses in the coming September. And I chose CHBE because I understood that I want to, I know I liked math and sciences, but I wasn't quite sure what I could do with them. and engineering is applied science, which gives me a sense of purpose in what I'm studying. And I chose CHBE specifically out of all the engineering disciplines because I hope to work on renewable energy and resources in the future. And CHBE offers me the foundational chemistry and biology, which is essential to clean tech, I feel, and also gives me the understanding of large-scale processes and how to convert lab-scale findings to real-life applications that has an impact that we could see in our lifetime, I hope.
All right, so maybe I'll go next. Hi everyone, my name is Mateus, and I'm in my 5th year in CHBE. I'll be graduating soon, so that's pretty exciting. So why did I decide to do chemical and biological engineering? Well, I kind of always knew that I wanted to become an engineer, but I didn't know which one. And in high school, I liked chemistry. I figured out that there was chemistry in chemical engineering, so I decided that that was the way to go. The truth is that we don't do that much chemistry per se. It's a lot more systems, as Dr. Potvin said. And one of the main things that I love about this program is how broad it is. I know the Gabriel touched on this a little bit, but there's truly anything needs a chemical engineer. And I heard someone once say that one of the main advantages of a chemical engineer is that you understand very small things. You can go to the nanoscale, understanding the molecules and how they interact, to huge systems such as a distillation column. So being able to go back and forth between those huge scales is truly important. Can lead us to many places.
I guess I'm next. Hi everyone, my name is Megan. I'm a 3rd year chemical and biological engineering student. I'm also currently on my co-op year, so I'll be coming back to CHBE in September to complete my 3rd year academically. Mateus stole my answer as to why I chose CHBE, but I think I can just elaborate a bit more on that. My main goal after getting my engineering degree is to kind of go into project management. And I personally don't have a preference for which industry, as long as it's like impactful and able to kind of contribute to society and or community in a positive way. And I think Mateus, as he touched on, there's so many opportunities where you could do chemical engineering. I remember my dad's actually a materials engineer and a project manager, and he was telling me that any project that you work on or any system that you work in will need some kind of chemical engineer. They're very versatile. You can go across any industry, and any of the skill sets that you have from this degree or any projects that you worked on, they're very transferable. So in my goals in wanting to be a project manager on big projects or whatever's gonna be in my future, CHBE kind of gives me that flexibility to go where I need to go with the same skill set and knowing all the different options and things that are out there.
Who's up next here?
I think I'm next, but Bhavya was a B, and he's here as well. I'm not sure if he wants to say hi.
Look, you're talking. How about you introduce yourself, and then Bhavya will be next.
So my name is Nika. I am in 2nd year and 3rd year concurrently right now. I was previously in integrated engineering for a year, but I've transferred over, and I think I chose CHBE because I'm interested in 2 kind of general areas, which I haven't really decided which one I'll go with, but I love, renewable technology and green energy and that kind of side of CHBE, but I also volunteer in a lab where I work on some biomedical projects. So I love the medical side of CHBE as well. So those are my 2 interests, and that's where I hope to go in the future.
Okay, what about Bhavya? Are you there? Yeah.
Yeah. Okay, so hi, my name is Bhavya and I'm a 2nd year chemical and biological engineering student. I remember I was just in you guys' place last year listening to Dr. Potvin's presentation. And for me, the main reason I took CHBE was the large focus on sustainability. Like basically, I already had an idea that I wanted to go into CHBE, And then being part of the design team and just talking with everyone, like they convinced me that CHBE was very large on sustainability, and I've seen that from what I'm learning and everything, there is a large focus on green energy, sustainability, as Nika and Matthias said. So that's what drew me in.
Great. So I'm glad to hear my presentation last year didn't scare you off. Who's next? Do we have any other students on here?
Nope, I think that's it.
That's it. All right. So, so how about we do this? So we can do an open Q&A now. I believe that's the plan. So we do have students here that they'll be happy to answer your question. I'd be happy to answer your question. We have Christina and Marlene who work for the department here. So I do have a question here that was sent to me directly. So there's two questions here. The first one being, can BCIT chemical technology grads transfer any credits towards the UBC program? So maybe that's for Marlene or Christina.
Okay. I'm Marlene. I am actually a chemical engineer by background, and I am right now the Director of Academic Programs with the Department of Chemical Engineering, and Christina works with us on trying to support students. So I'm just going to say a comment about the transferability of skills is that in my own experience, I have, with a chemical engineering degree, I've worked in many different industries. I've worked in the oil and gas industry, petrochemicals, specialized paper, consulting, and now I'm working at UBC. So I would say that chemical engineering, in my experience, was the best decision I ever made. I actually didn't know any engineers when I entered engineering, and so I didn't actually know what engineers did, but I liked chemistry and math, and that's why I'd selected chemical engineering. So I don't think there's any bad engineering. My son is an environmental engineer, but I think chemical engineering just definitely gives you a lot of flexibility. So the question about BCIT and transferability of credits, we would actually, for students coming into UBC, we have to refer them to the Engineering Advisement Office, the EAS. So if you just leave us your name, we can put you in contact with the right person to see what can be transferred over. They often won't do individual credits, but we'll look at a program credits.
Okay, that's great. So this is an anonymous kind of message. So maybe if you can send an email directly to Marlene with that question, she'll be able to answer. I have another question here from the same person, which is, will there be future opportunities in oil and gas? If not, where's the future of chemical engineering headed? So you know, that's a good question. So as for the future of chemical engineering, it is much broader than oil and gas. Chemical engineers were created because of oil and gas before. They needed an engineer that was able to understand everything and oversee the process and design the specialized equipment. So that's where chemical engineers came from. But that skill set, as we've been you've been talking to the students or hearing from the students, you see it's very versatile. It allows you to apply those skills everywhere. So the future of chemical engineering is wherever you can imagine it to be. So one of our graduates, this was a couple years ago, is working on a process to make lab-grown meat for kind of food, right? So these big processes to grow meat cells and try to produce this on a large scale. We have another one that's in mineralogy, right? Metallurgy, to kind of extract metals in a mining operation. We have another one working in renewable energy, right? So renewable kind of natural gas and things like anaerobic fermentation. So we have people that work on, we had one that worked for Tesla for a kind of co-op term, I believe, at some point. Like, the future is really, it's an engineering discipline that will go everywhere. Look up any company. I'm guaranteeing you there's a chemical engineering kind of somewhere once they reach a certain size to oversee all of these kind of projects. So are there still going to be opportunities in oil and gas? Yes. You know, we are transitioning kind of slowly away from things like fossil fuels, right, in favor of much more sustainable and probably more efficient kind of processes as well. But there is still a need for oil and gas for a lot of manufacturing products. And there's a lot of need for chemical engineers to make sure that we can extract oil and gas and use these resources in a sustainable way with mitigating the environmental impact that we have and make sure everything is good for the environment and for health. So there are opportunities in the oil and gas industry if you're interested. It's not the booming sector that it was, 30, 40 years ago, but there's still lots of kind of opportunities, and some of our graduates every year go to that industry. But the discipline is much broader than that. So long answer to your short question, but I guess you'll get that from any professor. All right. So we have a next question on my list here. And how different are both streams of the CHBE department? You were looking through the website and noticed Chem and Chem Bio have a lot of the same subjects. Yeah, so good question. So in kind of both of our programs, the second year is common for everyone. So just like your first year is common for all engineering, whether you're in the chemical engineering program or the chemical and biological engineering program, your courses are the same. That will really give you the foundation. So you'll do, even if you're not in the bio program, you're unfortunately going to have to take my bio course, my intro to bioengineering. If you are in the bio program, you're still going to have to look at chemical systems. So the programs are pretty well aligned, which is when you graduate, you are going to graduate as a chemical engineer, but you are going to graduate with some specialization in the kind of fields that you're interested in. So if you're in the bio program, you're going to take things like bioprocess design, bioreactor design, you're going to have some bioprocess labs. Your fourth year kind of capstone project is going to be on a bioprocess. Whereas if you're in the chemical stream, you'll be doing advanced process control, chemical reactor design. It's still applying those same rules of the universe, it's just a different applications. The other thing is in fourth year, you'll get to take a bunch of technical electives. So even if you're not in the bio program, but you decide you're interested, you can take some of the bio courses then as your technical electives, right? You select from a list. So yeah, another long answer to a short question, but there are a lot of similarities. They only diverge from 5 courses, I believe. But there's opportunities to kind of mix. So there's no bad decision here. And there's an opportunity at the end of second year to apply to transfer if you decide after first year that you would like to transfer to the other program. So hopefully that kind of answers that question, Laura. Thanks for that. Okay. How many credits does CHBE do? Is it more or less than the average credits for second year engineering specializations? That's probably for Christine or Marlene. It's
comparable. We're in the average. If you look at all the different programs, we're kind of average. And our elective, so we have our fixed program, and then we've increased the number of electives that students can take. So in their fourth year, by their fourth year, they have 12 credits, which is sort of middle of the pack again as well. Yeah, so don't worry, we'll work you hard, but not any harder than any other kind of discipline. So that's good. Hopefully that answers your question, iPhone 1. All right, next question on my list. Edith, if I want to go to the medical side of CHBE, what courses should I take? So your first year is the same, obviously, for everyone. In second year, it's going to be the same across the board. If you're interested on the medical side, I recommend you go to the chemical and biological program, right? Because you'll get more exposure to the bio side, which includes a lot of these kind of medical applications. Doesn't mean if you go to the other program, you can't work on medical applications, but it helps to go on the bio side. You'll see from the list of technical electives kind of what courses are available that kind of align with your interests. Something you might consider is we have a lot of undergrad design teams that work on kind of biological processes. There may be, I don't want to kind of guarantee you anything, but for your technical electives, there may be opportunities to take courses from something like biomedical engineering if there's something that you want to do, although we do offer a lot of kind of options that will likely kind of interest you. But the SCT is pretty comprehensive, right? So other than those technical electives, you're going to get a good comprehensive program that's going to lead you there. And there's an opportunity to work in labs. Actually, that's something we haven't talked about much, but we have faculty members, professors that are doing research in all sorts of medical applications. You may have seen in the news, we have some professors that work on those biodegradable masks, right? We have a professor that's working on vaccine technology. We have another professor, Dr. Jane Hill, who just started. She does medical diagnostic tests based on your breath.
So you breathe into a machine and it tells you whether you have tuberculosis or something like that, right? So there's lots of medical applications, and we're a department where the culture is we try to give students as many opportunities as possible. So you get a chance for, you know, summer kind of internships, or your thesis project in 4th year, or co-op terms in the lab. So there's opportunities for things like that. So yeah, hopefully that kind of answers your kind of question there. If not, please post a follow-up. Okay, so question here by Aurora. Feel free to ask students too, right? If you don't believe me on anything I say, students will give you their own opinions. So Aurora here, how hands-on would you say work opportunities have been? Do you have any experiences that stand out from co-op? That's for students. So any one of you want to talk about co-op terms and the kind of hands-on work you do?
Yeah, for sure. I just messaged a little later saying that I could jump into a breakout room, but guess I can answer it here. It is variable depending on the type of work position that you find. Personally, I've had internship / co-op experiences at research labs, 1 term in lab doing experiments almost every day, running experiments, analyzing data, very hands-on. And with COVID, I was with the same research group, but my project was on computer simulation. So I was able to work from home, and it worked out perfectly because COVID happened. So it varies. And my current co-op position is in person, very hands-on. They have a pilot scale operations and lab scale operations. And the people there are super nice. And I expressed interest in building things. I saw people building things with plastic sheets, metal sheets, and welding. I got to weld 2 pieces of metal together for the first time in my life, even though the glove that I was given was like way too big, and I had 2 of my last fingers stuck in the like ring finger slot in the entire time, and I didn't notice until afterwards. So yeah, hands-on experience definitely possible with CHBE positions, and depending on the employer, depending on the work culture there, you can be involved in more or less than depending on what you want.
That's great. So Megan, you said you're on your co-op. Do you want to talk a bit about what you're doing now?
Oh,
Sure, yeah.
Megan, just before you do, I'm just going to open some breakout rooms. So nobody needs to do anything. It's just you might get an alert. Go ahead, Megan.
No worries. Yeah, so kind of emulating exactly what Amelia says, depending on like what you want to do and what type of hands-on experience you want to have. You can have either your entire position is hands-on, like you're in the lab, as Amelia was saying. I have a friend who was working in the agriculture sector and was like in the field every day, kind of analyzing and looking at crops. And that was like really hands-on. For my positions, it's been a lot more, I guess, project management, because that's a bit more of what I kind of want to do. Not to say I haven't had any hands-on experience, but with COVID, it's been a bit more difficult to get that. I'm currently working for Fortis BC. It's a natural gas utility here in British Columbia. It's the biggest one out here. So most of what I do, I'm a gas standards co-op student, so I kind of look and make sure that all the products we're using are up to code and that they're following the right procedures, because with natural gas, that kind of stuff's really important, and it could get a little dangerous if we're not following the right procedures. So depending on what I need to do, I'll be writing up specifications on my computer at home, or I'll be going out into the field to test a new product to see if our operations personnel like it, or I'll be in our warehouse. I'm actually helping design some meter set designs right now and helping order the parts to put that together. Very your hands-on experience. So if you want your hands-on experience, you can easily get it going to a co-op that's in person doing a lot of work. Or you could even have like one of those classic office jobs like I kind of have, where you are doing some in-person work, some stuff at your desk or at your work computer.
Thanks a lot, Megan. So that kind of reinforces, right? Lots of opportunities to do a lot, right? So it's a very versatile discipline that way. So next question, how do you think chemical engineers would play a role in nuclear technology? You can have a great kind of chemical engineering kind of career in nuclear technology, right? It's a process. It's a nuclear process, so a little bit different than conventional chemistry, but it's still a nuclear process where you're going to design the system that's going to bombard your fissile material with kind of particles, the heat that's generated has to go somewhere. That's right inside chemical engineers kind of toolbox, right? So we design systems to absorb that heat, to use that heat to generate electricity, for example. So that whole process, sure, chemical engineers can work in there, no problem. The nuclear waste, right? Disposal of the waste. That's a process to come up with ways to what can we do with that nuclear waste. This is something that chemical engineers can work on as well, right? Storage and disposal of waste in all its forms. So absolutely, chemical engineers can work in that. So I got a direct. Yep, go ahead.
Just to add, I have a friend that was in CHBE. She still is in CHBE, that was working in the Ontario power generation system. So if you're really interested, I can put you in contact with her.
Fantastic. So this is Laura, I believe. So if you want to send an email to or send a message to Matthias, he'll put you in touch with someone. That's great. Thanks, Matthias. So I got a yep. Go ahead.
I was just going to say, Dr. Anthony Wax is one of our faculty, joint with math, and he has a lot of experience in the nuclear industry.
So yeah, so it might be an opportunity to kind of work there. Okay, so I got a direct message. How many courses per term per year? It'll vary, but it's usually between 5 and 7. I don't think we have any eight course terms in our schedule now. So let's say usually 6 or 7 per term. That's pretty standard across engineering. All right. So next question here. Is it possible to work with a professor on the research in second year CHBE, or do professors prefer third and fourth year? That's hard to answer, right? So especially now with COVID, things are different, but things are coming back. So I hesitate to tell you something specific. We do have some second years that work with professors. Depending on the type of work and what's available, you can imagine it might be a little bit more competitive for third and fourth year because they come with a broader skill set. But we do have some second year students that work in labs. So yeah, so it's possible. I don't have a job to offer you right now, but certainly something to follow up on once you're here. Yeah. So maybe any of the students here, like, did you work in a lab in second year? Because Amelia, you're working now, but you're at the end there, I guess.
Yeah, I worked in a lab after my second year, in the summer after my second year. And I got that opportunity to work in the lab because I cold emailed the professor twice and went to his office to bug him, which I guess isn't really doable with COVID. But yeah, just try it. Professors are generally very open to talk to students. They might not reply to you because they get like hundreds of emails every day, but if you somehow get in touch with them, maybe ask for a video call. They're very kind human beings. Yeah, definitely encourage you to reach out to professors if you're interested in their work.
So I used to laugh at my PhD supervisor because I'd be in his office. He said, yeah, I'll send you a file right now. And I would walk away, and then 2 hours later, I still haven't had it. So I go back and I ask him, he's like, oh yeah, I'll send it to you. Walk away, still don't get it. So you have to sit there and wait till it does it in front of you. And I used to laugh at him, and now I'm exactly like that. So, don't take it personally if professors don't forget to answer an email. It's not because we don't care, but usually we try to get back to you kind of quickly. Okay, I got a few.
Sorry about that. For the next question, Nika, that was just here. She's a second/third year student, but she volunteers in a lab, and we just finished doing a video about her. So this is a shameless plug-in. I'll just put the link in the chat box in a second.
That's great. So yeah, so second years do have kind of lab experience. Okay, I got a couple of direct questions here. If you don't want to post them to the general chat, that's fine. I can take a look at them. So we have one from, okay, I won't name the names if you're sending it direct here. So I heard it is possible to become a cosmetic chemist with a CHBE degree to do things like creating shampoo, lotions, and other personal care. Wondering if it's really possible. Sure, that's another process. You're going to learn the thermodynamics, the mixing, the chemical reactions. You'll learn the polymer chemistry. You're going to learn the physical characterizations of kind of products. You'll learn experimental design. And so that is a perfect industry for a chemical engineer to kind of go at. So if it's something that you're interested in, fantastic. So actually, one of the things, I mean, it maybe not directly relevant, but my background for like my PhD was growing microalgae, so single-celled kind of plant cells, right? So they're kind of like a mixture of bacteria and plant cells, and some of the molecules they make are pigments, or color molecules. So one of the species I was growing, the kind of, and I grow with my students in my fourth year lab course here, was astaxanthin, which is a pigment that makes a red color, right? So if you're interested in developing makeup and stuff like that, if there's red color, there's some of that molecule that comes from the algae I was growing. So it's pretty cool to be able to do that kind of stuff and to see the whole process. So absolutely, if this is something that interests you.
So I just want to make a comment. Amelia's next co-op is with Procter & Gamble, and Procter & Gamble is a huge consumer company. They make all kinds of cosmetics and things like that. So they make Tide, and they used to do Duncan Hines, the Sunny D. So they have just a tremendous range of products that you wouldn't even know. But if you walk into your house, you're going to have something that's from Procter & Gamble. And so they hire a lot of engineers, and they hire a lot of chemical engineers, and they like to move their engineers around, but they have a lot of cosmetics products as well. For example, oil of Olay. And just another plug for chemical engineers. The CEO of Avon is a chemical engineer. One of our students who graduated 3 or 4 years ago, she went back to Korea, and she works in production of cosmetics. So I think she's a manager there. So yeah, it's an interesting field, yeah.
You know, it's a product, right? There's not much difference between, you know, designing a system to make face cream than it is to kind of make, you know, craft dinner, or it is to make whatever kind of chemical industry you're kind of thinking of. So that's why we're able to apply those process design skills kind of across the board. So, so that's great. Okay, so I have another direct question here next on my list. I have never taken a biology course, but I'm interested in biological and chemical engineering. Will that be a serious handicap? No, like you'll see in second year, we start, you know, you might have a little bit more trouble than someone who's kind of done grade 12 bio, for example. But we know where students are coming from. I teach that kind of bio course in first year. You'll be fine. You know, if not, like I'll have extra office hours that kind of help you through it, right? It's not it's not a big deal. So please don't be deterred by that. You'll be fine, right? You also won't be the only one without a bio kind of background. So don't stress too much about that. I guess I would hesitate, you know, maybe what you can do if you're worried about the bio content, ask Nika, because I think she's in my class right now, my kind of bio class. And so if you do it in a breakout room when I'm not there, she'll be honest with you as opposed to kind of put her on the spot here. Yeah. Okay. Okay, so are there, Edith asks, are there any volunteer opportunities in CHBE that are open for high school students? Do you mean like having high school students come and volunteer in CHBE? Because I don't think we have official kind of volunteer positions. What I've done with several high school students in the past that really had a project they want to do, or kind of something they want to try, this was pre-COVID, mind you, when they would contact me, we would arrange something like they would come to the lab with some friends or with their parents, and I'd show them the lab, and we do some experiments related to what they want to do. So I'm happy to kind of offer that if it's possible, but you know, we have to wait till COVID restrictions are lifted, of course, and things like that. But Marlene, do we have any positions for like volunteer positions for high school? That's the first time I hear about this.
No, actually we don't, but we have had other faculty more or less sponsor students to come in and do experiments and things like that. The other thing that we've supported in the past is the Sanofi BioGenius competition. So their high school students are lined up with a faculty member, and they do a research project, and then the competition is to present their research, and there's a scholarship opportunity for the people who win that competition. So we have been heavily involved and have sponsored Sanofi BioGenius, the local competition, the BC Lower Mainland competition. We've sponsored that for, you know, quite a few years.
Yeah, so there's opportunities for that, but maybe not volunteers. And now that I'm looking at the participant list, just because of my earlier comment, I believe Bhavya and is in my bio course as well, so you can send him a message too. And so Megan took it last year, so you have plenty of people who will hopefully tell you what I told you, but they can be honest with you there. Okay, so I have another direct question here, which is I'm colorblind, and I just wanted to know if there are workarounds in the program and in the industry wherever issues may come up. Look, yes, of course, we work with our students to make sure the material is accessible and everything's going, so please don't stress about this. I know it sounds less than convincing when I say this from a position of presenting the program, but we really do have a culture in the department to bend over backwards to help our students. So if there's an issue like this, please don't worry, we'll make sure you can get through it with no issue. As for industry, kind of it's same thing, right? You're not the only one. These issues kind of come up, so I can't promise you or tell you exactly what it's going to look like in every industry, but you shouldn't worry about that or let that hold you back, right? Okay. So so the competition, is it still open during, okay, Marlene's kind of asking. Yeah, I'm not sure actually this year. We won't be hosting it in person this year, the competition, but we have to look if it's open. Okay, so we're at the end of the question list. So any more questions? So you've gone through a year of UBC, so you already know that as professors, we're very comfortable sitting around in awkward silence, but they would be better if we had questions.
I forget who was asking about the iGen CHBE debate, but if you would like, I am happy to help in a breakout room if you have specific questions.
What I can also do is, so right now we're in one of our labs, right? So you can see behind me, we're in one of our kind of process labs. We actually ran these kind of online labs that were kind of a lot of fun. A lot of fun for me, kind of at least. And so, but we do have a kind of bio facility. Is anyone interested in me carting this over so you can see the bio lab? Is that something that might interest someone? Change of scenery, yeah. Mateus, yeah, you want to see it? Okay, so while we're waiting for more questions, I will drag this over, and so you can see our other facilities there. Okay, so yeah, so that's great. So yeah, people are chatting here about the kind of student community. If I can add my 2 cents here, obviously I'm a professor, so don't believe anything I say, but I've worked with a lot of universities kind of over the years, and the community and the elsewhere. It's really cool to see the students here. It's top-notch kind of students. The things that they kind of work on are really great. So from my perspective, this is a great program. Okay, so I have a direct message here that says about the wastewater, that it does answer the question, and the labs are so technological. So yeah, we you know, as engineers, we work with technology. I think you'll find that in most disciplines, but we have the coolest toys, but you'll see kind of it's very technological everywhere, but you will get to play with all sorts of stuff. And if there's something that's not officially scheduled, there's usually a way to arrange for you to get some experience on it. So. Okay. Yeah, and just to clarify to Megan's point there, the goal is, like, the expectation is that everything will be online. Sorry, everything will be in person in September, right? So slip of the tongue there, you know, knock on wood. I don't know if there's any wood here. But everything is supposed to be in person. We're looking forward to greeting you kind of in person. It's not that online was a failure. I think there was a lot of good work that was done. But like everyone agrees, it will be better in person. So that's certainly the goal here. So you'll get to visit these technological surroundings I'm in now. Okay. Any other questions or things you'd like to chat about? Maybe if anyone joined late, I'll put my email address again in the chat. So so if any of you want to, you know, you wake up in the middle of the night with a question you should have asked, please send me an email. Happy to discuss or put you in touch with with someone who can answer the question better than I can.
Personally, in the last while, I've had a lot of questions from first years asking how difficult is the program in comparison to others, and I thought I would touch on that quickly. I don't think you should be picking a program based on difficulty. Really look into, you know, the courses that you would be taking and the type of jobs that you might get and really what you're interested in, because at the end of the day, there's a great community that's going to help you out and get you through it, and you shouldn't be worried about that at all.
Build on what Nika talked on. I know someone was asking me earlier about if it was okay to take a lighter course load and maybe don't do the 7 and 7 or 8 and 7, whatever it is for second year now. And that's also a possibility. There are students who are extending their degrees by a year and they're taking a lighter course load in order to balance it if that's better for them in order to be successful, or taking some summer courses to lighten up your load during the school year. If you work closely with Christina and the CHBE office, I'm sure they'll be able to put together a schedule that would work best for you and for completing your degree. That's like one thing that I've like noticed is it's very flexible in completing your degree, but also like CHBE always works extremely closely with the students, and I've definitely felt that as a student in this program. So if you ever need like support with classes or anything else, the CHBE department is usually like a really good resource to go to if that's something you want to pursue.
Sorry about that. I just got back. So I did get a question. Mateus asked where I got my black t-shirt. And so I have a reputation in the department for my amazing fashion sense and that I wear black t-shirts every day. And so I'm glad to announce to everyone, I just got a shipment in, about 15 of them from Mark's Work Warehouse at $10 a piece. So good deal. Yeah, I'm not big on accessorizing either. All right, do we have any more questions? I lost all the chat when I kind of disconnected. So if any were posted since I don't see anything, but no, we're still good. So what's the plan here? Are we just going to virtually hang out now, or do we have any more questions?
Don't see any other questions. If there's somebody who'd like to chat with a student directly, you can go in a breakout room yourself, or you can let us know that you'd want to go in a breakout room with a student. Otherwise, you can just ask your questions in the main room.
And if not, we'll stick around as long as there's questions or a desire to kind of speak to us. But so hopefully this was a useful session, right? Hopefully we answered your question, give you a bit of a sense as to what goes on. You got to meet some students. I know the decision seems big of where you're going to go and where it's going to allow you to go for the rest of your discipline, and I get it. And although there's no bad choice, I will argue that chemical engineering is an excellent choice and will allow you to do all sorts of stuff you're kind of interested in. So in case I wasn't clear so far on this.
I know I received a couple of questions about design teams, but as Dr. Potvin said, I also like hearing myself talk, so I can talk about that after people are interested in hearing more information about CHBE design teams.
Yeah, but so I would like, so you're in I think a bunch of them, like if I remember correctly.
I'm in a bunch of extracurricular activities. Yes, I'm in one design team in CHBE Chemicar. Me and Nika are actually the co-captains for that. Bhavya is our lab, one of the lab team leads, and Mateus is the president of Envision, who basically trained me and Nika when we first joined the team a couple years ago.
Fiona is on here too.
And Fiona, as well as first year on the call, she's on our circuitry team. So got quite the Chemicar community building. Other than Chemicar, there's a ton of other really cool design teams at CHBE that you can get involved in. Off the top of my head, there's BioT, Green Jewel, Biomod, Agrobot, and then there's also some other clubs you can join, like Engineers for a Sustainable World, or Engineers Without Borders, EWB. So there's a lot of other ways you can get involved. Chemicar, we build oh, hi Fiona, I see you in the group chat. Chemicar, we build a shoebox-sized car completely built on chemical reactions. Our main feature is we basically build a homemade car to power the car to move around. That would be our main feature.
Homemade battery.
Homemade battery. Sorry, did I not say? What did I say?
You said car To build a car.
Oh, homemade battery. I'm sorry. It's been a long day. Yeah, so we build homemade batteries to power a car. BioTea is a beer brewing group, so they look at that beer brewing process. And I believe they're also in the future of hopefully building an app that kind of goes along with that.
They want to use machine learning to make like beer. So I think the dream is you're going to input the kind of beer that you like in the system, and the machine learning system is going to tweak all of the parameters automatically so you get like a perfect, unique beer for you. And so, you know, beer, a lot of people dismiss it, but like, this is a chemical engineering process. You're transforming resources in there, and the tools that they're using, like machine learning and kind of artificial intelligence, like these are things that chemical engineers work on and work with. So it's really cool what they're doing.
Yeah. In regards to like high school students, I like personally, I've never met a high school student participating in a design team. However, it doesn't hurt to reach out. I would say like if you're like, oh my God, I really want to join this, or I really want to learn from them, or do a project with them or something, then it doesn't hurt to ask.
Yeah, I don't think I've ever heard of high school students participating in university extracurricular clubs. But if you are a high school student joining UBC, there are a ton of extracurricular clubs and groups that you can join. I think there's over 300 clubs at UBC to pick from. So if you're interested in skiing or canoeing or sailing or going for a walk, I'm sure there's some kind of club or group that you could join and get involved with. Specifically in engineering, there's a lot of there's some really big groups or organizations you get involved in. Design teams is one of them. Not every student is in a design team. That's not something you need to do. I personally have enjoyed every moment of being in a design team. So I would recommend it, but it's also not necessary. I don't even know how many design teams there are. There's so many, and there's so many cool things that they're working towards. So there's easy ways to get involved with that. As I kind of mentioned before, for other clubs to get involved with, there's Engineers for a Sustainable World or Engineers Without Borders that really kind of works on building the UBC engineering community along with just communities that are in British Columbia or in the Lower Mainland, and just like looking at real life problems and how to support that socially. There's also a bunch of I guess you could say student government clubs or positions that you can get into. There's the Engineering Undergraduate Society, which is just for all of engineering. You can get involved in that as a first year or through elections and positions as you go through your degree. There's also student organizations or councils in every single engineering discipline. So we have the CHBE undergrad club, which they run events, they reach out to students. They host this really cool thing called Beef and Pizza. Basically, you eat, if it was in person, you'd eat pizza and then you beef. So you kind of talk about some concerns that may come up in classes. Professors will be there to also address any concerns or work with students. That's something that I found very useful and very valuable when I was still in school. Been away on co-op for the past year, so don't know how they're doing it this year. But there's a ton of ways that you can get involved as a student. I know that I do too much outside of school. My sleep schedule is questionable, but I know that in addition to classes, it's really important and fun to get involved in design teams or extracurriculars as well. Or at least that I found great value in doing that.
So Mateus might actually talk a little bit about extracurriculars from the perspective of being involved in the undergraduate research types of things.
Yeah, so pretty early on, I figured out that I wanted to follow more of a research path. So I worked my ways towards trying to get as much research experience, and that goes from talking to profs and just doing a thesis, as Gabriel mentioned, where instead of taking two technical electives in fourth year, you work with a prof on a research project of your own. So that's super helpful. And I also participated in there's a club that is more related to sciences. They're called Undergraduate Research Opportunities, URO. And their goal is, as the name states, they're just trying to get undergrads into labs and just trying to get them as much research experience as possible. So they'll look at your resume, they will help you, they have workshops and things like that. So I would strongly recommend reaching out to them and trying and participating in their events. And in terms of, so this is a little bit of a shameless plug. So in CHBE we have EBC and Vision, and we are the student chapter of the American Institute of Chemical Engineers. The goal of ICHE, American Institute of Chemical Engineers, is to provide a network for students to reach out to professionals and trying to get them jobs, and just they have a bunch of free courses online as well. Very often I find myself looking through papers and I realize that it's from ICHE. So our goal here as a student chapter, we branched off of Chemicar in around 5 or 6 years ago, and this year we've been really focusing on getting students more professional development opportunities. So somewhat related to co-op and PD, the department. I'm not sure if it's the department, but the PD team. So we've hosted a few talks that I think were very successful. And in the past, we've been helping the teams who are Chemicar, Biotech, Green Jewel, we started from there. So our goal is to help the teams. For the past year, so we've been more focusing on the PD side and allowing the team to do their own thing, and I think that has really helped. But yeah, anyways, Envision is something that has benefited me tremendously, and I know that it has for Megan and Nika as well. For example, the second year research thing that Nika did was from Envision, well, branched off of an Envision event. So just really networking and just meeting people from a professional network, from a professional side, and becoming friends with people helps you in ways that you can't even imagine. So I would highly recommend joining design teams and all sorts of things.
There's another group which is not necessarily a design team, but there's something called Innovation on Board at UBC, and so the organizers, it started, some chemical engineering students started it, and it's an entrepreneurship program. So if you're interested in, creating a business in the future, this is a really great opportunity. They set up workshops in the fall, and then they do they have a competition with posters, and then they have a pitch competition. They just did it in February, and it's kind of like a Dragon's Den pitch. And so that's been a really interesting new student initiative that we've seen. There's other sort of extracurricular groups, like Women in Engineering is another one. So there's a pretty broad range of like more technical to sort of entrepreneurship opportunities for students.
One thing I always recommend is, if you go to these events and if you participate in all these teams, try and reach out to people that you're, interested in their work. And it's the way that you get opportunities. Like I was a first year when I went to a competition for the design team, and then I just happened to talk to someone who was working on a research project there, and then I ended up volunteering with them for 1.5 years. So it's really important to, if you're not sure what you want to do, even to try stuff out, ask people, hey, I really want to learn to use this piece of equipment, Dr. Potvin. Can I like pick your brain a little bit on this? Or Megan, I really want to join like NGU, the wellness club. Like how do I get involved with that? So really, if you're not sure what you want to do, try and talk to as many people as you can.
So maybe it is 7:30-ish. So, and I don't think we see many other questions in the chat here. So maybe that's a good place to wrap it up. So yeah, I want to thank all of you for coming. I know you spent a lot of time in front of your screen, so we thank you for suffering through it a little bit more to talk to us today. We really do hope to see all of you in our department in September. But in the meantime, you know, best of luck with the rest of the term. If you do have any questions, please don't hesitate to reach out. We're hopefully we left a friendly impression here, and we'll answer your questions. And yeah, I think that's a good place to stop. So have a good night, everyone, and a good weekend.